Welcome to this personalized deep dive. If you take a look around right now, I mean, artificial intelligence is just absolutely everywhere.
Yeah, it really is.
It's writing complex analytical articles, composing original music, building software apps from scratch, and honestly answering highly technical questions way faster than most of us can even type them.
Right, the velocity of the adoption is staggering.
Exactly. And because of that sheer velocity, there is this very persistent, very human question circulating right now, which is, if machines are getting exponentially smarter every single day, where does that leave us?
It forces a mirror up to our own utility, honestly. When you introduce a technology that effectively commoditizes cognitive labor stuff we previously thought was the exclusive domain of the human mind, it challenges our foundational understanding of value.
It does.
But framing this as a zero-sum competition, where a machine gaining ground inherently means a human loses it, that relies on a deeply flawed premise. It assumes intelligence is this static, finite resource.
Which is why we need to completely reframe the conversation for you today. The actual question we should be asking isn't whether AI will outsmart us in a vacuum. The real question is, how can humans become smarter in the age of AI?
Yes, that's the core of it.
Because the reality is, our definition of intelligence is undergoing a massive paradigm shift. It is no longer about hoarding and memorizing information. I mean, AI already has that market cornered.
Really?
What matters now is the architecture of our thinking, our biological capacity to learn, and how we leverage these synthetic tools.
Yeah.
Okay, let's unpack this because we have an incredibly dense, multidisciplinary stack of sources curated specifically for you to map out this exact shift.
The cross-section of research we are synthesizing today is genuinely remarkable. We will be analyzing recent neurobiological papers from the eCentury Publishing Corporation detailing adult neuroplasticity.
Alongside some really rigorous Harvard research examining the looming threat of cognitive atrophy.
Right. And we are layering that with macroeconomic forecasts from Deutsche Bank, plus an incredibly dense, highly technical archive mathematical proof that challenges the theoretical limits of artificial general intelligence.
We've also got a fascinating comparative case study on poetry generation from the UCLA Reasoning Lab. And finally, some pragmatic projections from Forbes regarding the human-centric workplace of 2026.
It's a heavy stack.
It is, but the overarching mission here is to dismantle and reconstruct what it actually means to be smart. Just think about the historical precedent for a second.
Oh, absolutely.
For centuries, if you possessed a vast mental library of facts, or if you could translate multiple languages on the fly, or do advanced calculus in your head, society immediately elevated you as a genius. Knowledge storage and retrieval was the ultimate currency.
But today, a machine can parse billions of parameters, search the entirety of digitized human history, and output a translated mathematically flawless synthesis in a fraction of a second.
Right. So if raw data storage and rapid computation are no longer our primary advantages, we are forced to isolate what remains uniquely human.
And what remains is the origin point of thought. It's genuine, unprompted curiosity, intuition forged through physical reality.
Connecting wildly disparate ideas.
Exactly. The ability to connect seemingly incompatible ideas from different domains, and the nuanced emotional understanding required to give those ideas actual meaning. The individual who knows how to interrogate a system, who knows how to ask the jagged, unpredictable questions, will hold significantly more power than the person who has merely memorized the consensus answers.
Let's start by looking at that changing definition through the lens of Moravec's paradox. This is a concept heavily referenced in both the Deutsche Bank report and the RCIF papers, and it completely subverts how we traditionally measure the difficulty of a cognitive task.
We tend to think advanced calculus is hard and walking upstairs is easy. Hans Moravec, along with researchers like Rodney Blum and Marvin Minsky, articulated this paradox back in the 1980s, and it remains the central irony of artificial intelligence.
Tell us about that irony.
So, Moravec observed that high-level, conscious reasoning things we consider to be the pinnacle of adult human intelligence, like playing grandmaster-level chess, passing a bar exam, or solving complex algorithmic logic, that actually requires very little computation to automate.
Which is counterintuitive.
Highly! Because conversely, the low-level sensoromotor skills of a one-year-old child, like recognizing a face in varied lighting, maintaining balance while walking across a cluttered, unpredictable physical room, or instinctively reading a subtle shift in a parent's emotional state, Those require staggering, almost incomprehensible computational resources to replicate in a machine.
Okay, I want to push on that, though, because we constantly see Boston Dynamics robots doing backflips now, right? And we have AI systems powering autonomous vehicles. Hasn't deep learning essentially solved Moravec's paradox at this point? We aren't just building chessbots anymore.
It is a valid pushback. And the Deutsche Bank report does highlight that the transition from traditional machine learning to deep neural networks has allowed us to finally make inroads into sensoromotor tasks.
The zettabyte era, they call it.
Right. An explosion of unstructured data combined with massive parallel processing power via modern GPUs. This allows deep learning models to learn from vast amounts of empirical data rather than relying on brittle, hand-coded rules.
Okay.
However, they haven't solved the paradox. They're brute forcing their way through it.
Brute forcing it.
Yeah. Think about it. A human toddler learns the physics of a room through a few minutes of messy, embodied interaction. An autonomous vehicle requires millions of miles of simulated and real-world driving data, petabytes of video rendering, and constant sensor feedback just to avoid mistaking a plastic bag for a pedestrian.
That makes sense. The computational efficiency of the biological brain in navigating physical reality is still orders of magnitude superior.
Because nature spent billions of years optimizing those survival skills, we don't have to consciously calculate the physics of gravity, friction, and momentum every time we take a step. It is baked into our evolutionary hardware.
Whereas abstract logic is a very recent evolutionary overlay for us. It's conscious, it's rule-based, and because it follows strict symbolic logic, it's actually much easier to reverse engineer into silicon.
Exactly. And while deep learning has pushed the boundaries, there is a theoretical ceiling approaching, which brings us to the Arcust paper titled On the Computability of Artificial General Intelligence.
Artificial general intelligence, or AGI, which is essentially the holy grail for the tech sector right now.
Right, a system capable of matching or exceeding human cognitive capabilities across any economically valuable task. But this paper presents a deeply rigorous mathematical proof arguing that true AGI, specifically defined by the ability to generate fundamentally new knowledge, is mathematically impossible within our current algorithmic paradigms.
Wait, hold on. This is where I have to play devil's advocate. We just saw AI models from major tech companies discover thousands of new crystal structures for potential use in batteries. We've seen AlphaFold map millions of protein structures that human biologists hadn't cracked yet.
Yeah, those are massive breakthroughs.
So how does that mathematical proof hold up when AI is demonstrably producing new scientific knowledge?
That is the exact distinction the authors of the Arcsiv paper meticulously deconstruct. We have to separate interpolation from extrapolation.
Okay, break that down.
What AlphaFold and the materials science AIs did was interpolation. They mapped complex permutations of known physical laws within a strictly confined existing parameter space. They explored the latent space of the data they were trained on to find optimized combinations that humans hadn't physically had the time to calculate.
Which is valuable.
Incredibly valuable, but it is fundamentally combinatorial. The AI did not invent a new physical law. It did not create a new paradigm of biology.
Oh, I see. So it's like having a massive box of Legos. The AI can build a million different incredible castles that no one has ever built before, far faster than any human could.
Yeah.
But it cannot invent a new fundamental shape of a Lego brick that wasn't in the box to begin with.
Precisely. The researchers mapped this out mathematically, anchoring their proof in the limits of computation established by Turing and Gödel. An algorithmic machine-computable process is bounded.
It can optimize, permute, recombine.
Right. It can display existing functionalities in highly novel arrangements. But it cannot structurally generate a brand new functional capability that was not implicitly present in its initial code architecture or its training beta distribution. It cannot originate a paradigm shift in a vacuum. If we connect this to the bigger picture,
Yeah, please do.
the implication there is staggering. If algorithmic AI is mathematically confined to the boundaries of its dataset, yet human beings historically have generated entirely new fields of science out of nothing, authored new paradigms of art, and conceptualized quantum mechanics when all prior data pointed to classical mechanics, what does that reveal?
That we aren't just algorithms?
It suggests that human general intelligence is a mathematically incomputable process. Our cognition operates outside the strict bounds of algorithmic determinism.
Which completely shatters the idea that the human brain is just a fleshy computer running wetware code.
Hmm.
We are not just localized large language models predicting the next most likely action based on our past data.
Not at all.
Because if we were, we would never have invented anything truly disruptive.
Yeah.
We would have just endlessly optimized the stone tool.
Exactly.
So if AI is permanently bound by its training data, then the most highly valued humans of the future won't be the optimizers. They will be the extrapolators, the ones possessing extreme cognitive flexibility.
Which brings us to the biological reality of how we actually achieve that cognitive flexibility and how it differs entirely from machine learning. We have to examine the neuroscience of learning, specifically focusing on the E-Century review on neuroplasticity, because the most critical skill anyone can cultivate right now is learning how to learn.
Let's get deeply technical here, because comparing human brain plasticity to AI plasticity highlights the fundamental flaw in how we talk about machine learning.
Yes.
When we say an AI learns, we are using a metaphor. In a deep neural network, learning is a sequential mathematical optimization process. When the network processes data, it measures the error of its output, and then it uses a calculus mechanism called backpropagation.
Right. It calculates the gradient of the error and mathematically adjusts the numerical weights and biases of its artificial connections to minimize that error next time.
It's a localized mathematical simulation.
Compare that rigid sequential process to biological neuroplasticity, which is an intensely chaotic, parallel physical reshaping of an organic environment. The E-Century paper details mechanisms that algorithms cannot currently replicate. First, you have neurogenesis,
The actual physical birth of brand new neurons.
primarily in the hippocampus, and they continuously integrate into adult brain circuits based on environmental enrichment and learning demands.
And equally important is neuroapoptosis. This isn't just a software deletion.
No, it is a programmed biological self-destruction sequence where the brain actively prunes dead or unused neural pathways to increase the metabolic efficiency of the network.
But it goes so much deeper than just adding and subtracting cells.
Mm.
When you, as a human, learn a complex new skill, say playing the cello or mastering a new programming language, your brain is physically growing new dendrites to form novel synaptic connections. It is extending axons.
And it is actively increasing the myelination of those frequently used pathways. Myelin is the lipid-rich sheath that wraps around axons. When a pathway is heavily utilized, the brain reinforces that insulation, which exponentially increases the speed and efficiency of the electrical action potentials traveling down that specific circuit.
That is fascinating.
And all of this, the genesis, the pruning, the dendritic branching, the myelination, is happening simultaneously, modulated by a massive chemical bath of neurotransmitters like dopamine and serotonin, which encode emotional weight and physical context into the learning process.
I know computer scientists are trying to mimic this. The ArcSpiv paper on neuroplasticity in AI mentions techniques like drop-in and drop-out. I've read about this. They randomly drop certain artificial nodes out of the network during the training phase to force the model to not over-rely on any single pathway, essentially simulating neuroapoptosis or synaptic pruning.
Yes, and drop-in attempts to dynamically add nodes to simulate neurogenesis. But the paper concludes this is still just a technical approximation.
Right. It's a brilliant engineering workaround, but it is an approximation.
Exactly. A sequential algorithm adjusting probabilistic weights within a fixed digital architecture, even with dynamic nodes, is fundamentally different from a biological organ that physically reshapes its own cellular structure in response to real-time sensory input, metabolic constraints, and complex emotional states. The biological brain is engaged in continuous, embodied learning. Machine learning is episodic and disconnected from physical consequence.
And that disconnect is precisely why the Harvard Gazette article on cognitive atrophy is so alarming. Because AI is increasingly frictionless, because it can provide a highly plausible, synthesized answer in 2 seconds, there is a severe risk that we stop engaging our biological neuroplasticity.
We just let it do the work.
Right. The brain is metabolically expensive. It consumes about 20% of our energy, despite being only 2% of our body weight. It naturally wants to conserve energy. So if we outsource the heavy lifting of critical thinking to an LLM, our biological networks will literally, physically prune themselves. We will atrophy.
We actually saw a macro-level version of this with spatial navigation. Prior to ubiquitous GPS, navigating a new environment required building a complex cognitive map. It required engaging the hippocampus, analyzing spatial relationships, and processing environmental cues.
But once we outsourced that cognitive load to turn-by-turn smartphone navigation, our natural spatial reasoning capabilities measurably declined.
Exactly. The Harvard research, led by figures like Professor Karen Thornber, warns that we are now doing this with high-level cognitive processes.
Thornber's point about the drafting process is vital for you to understand. If you prompt an AI to write a first draft of a strategic proposal and figure you'll just edit it, you think you are saving time. But you are actively bypassing the critical friction of organizing your own thoughts.
That is such an important point.
The agonizing, messy struggle of staring at a blank page, failing to find the right word, restructuring a paragraph. That struggle is the literal biological mechanism that forces your brain to build the neural connections required for deep critical analysis. If you outsource the struggle, you outsource your own cognitive growth.
Which is why the researchers emphasize the learning models of children. A child doesn't ask an oracle for the perfectly optimized consensus answer. They engage in highly unstructured, terribly inefficient physical exploration.
They break a system to see its component parts.
They ask endless, seemingly nonsensical why questions that challenge fundamental assumptions. That messy embodied curiosity is the engine of mental agility. If we allow AI to sanitize our learning process by providing immediate, friction-free answers, we lose the cognitive agility required to handle novel, unprecedented problems.
And that mental agility is the prerequisite for the one domain where humans maintain absolute superiority. True, unpredictable creativity. This leads us right into the UCLA Reasoning Lab's case study on poetry, which I found to be one of the most compelling pieces of evidence in our stack today.
It's a brilliant study.
We've established that AI excels at combining existing data. But human creativity isn't just recombination, it's the collision of uncombined, highly personal variables.
The UCLA study is a masterclass in isolating that exact difference. The researchers set up a comparative analysis utilizing a highly accomplished human poet and a state-of-the-art large language model. They provided both with the exact same complex thematic prompt, centering on themes of grief, temporal displacement, and memory. The parameters were strict.
Let's look at the human process first. The human poet took months to finalize their piece, and the process wasn't a linear execution of a task. It involved drawing on highly specific, authentic, personal grief.
Flashes of fragmented memory triggered by completely unrelated daily experiences.
Right, like a specific smell, the change in weather, a conversation overheard on a train. The human was translating a chaotic, lived emotional reality into structural form.
Conversely, the LLM executed the prompt in a matter of seconds. It accessed its vast training data of human literature, identified the statistical markers associated with the requested themes, and generated a piece utilizing a mathematically perfect meter and a flawless conventional rhyme scheme. It optimized for the highest probability of fulfilling the structural requirements of the prompt.
But the real revelation came during the blind analysis. The researchers had expert literary critics analyze both poems without knowing the origin. The critics noted that the human-authored piece possessed what they called formal complexity.
The meter wasn't mathematically perfect. It stuttered in certain stanzas.
The rhyme scheme occasionally broke. But those structural flaws were intentional, utilized to mirror the unpredictable, jagged emotional weight of grief. The poem's syntax physically embodied the emotion it was describing.
And their critique of the AI-generated poem was devastating. While acknowledging its technical perfection and flawless iambic pentameter, the experts categorized the emotional resonance as relying on bland platitudes.
Bland platitudes. Ouch.
It was a highly sophisticated simulation of emotion constructed from the statistical average of how humans write about grief, but it lacked any underlying authentic origin. It was hollow because it was a probabilistic average, and true art rarely exists at the statistical average.
Here's where it gets really interesting. The lead author of the study, Keith Holyoke, introduces this brilliant conceptual analogy to explain this fundamental difference. He compares the output of an AI to a shoe, and the output of human creativity to a footprint.
It is a profound philosophical distinction. A shoe is defined entirely by its function. It exists to protect the human foot from the environment. Because it is defined by function, a machine can easily manufacture a shoe. It just has to fulfill the functional parameters.
But a footprint is not defined by a function. It is defined strictly by its origin. A footprint is the physical, historical impression left by an actual foot interacting with the earth.
So you can use a machine to press a piece of plastic into the mud to create a shape that perfectly mimics the exact dimensions and depth of a footprint. It might look functionally identical to the naked eye, but philosophically and literally, it is a fake.
Because a footprint requires an authentic origin point. Art, true creative synthesis, and genuine communication are footprints. They derive their actual meaning from the fact that a conscious human being experienced something and attempted to communicate it.
Exactly. If a machine writes a poem about the agony of loss, it is a forgery, regardless of how beautiful the prose is, because the machine is fundamentally incapable of experiencing loss.
This maps perfectly onto a historical debate in computer science. In 1949, the pioneering neurosurgeon Jeffrey Jefferson delivered an address where he stated, "Not until a machine can write a sonnet or compose a concerto because of thoughts and emotions felt, and not by the chance fall of symbols, could we agree that machine equals brain."
He explicitly argued that a machine cannot feel pleasure at its own success, it cannot feel grief when its physical hardware fails, and it cannot be made miserable by its mistakes.
Alan Turing actually quoted Jefferson in his famous 1950 paper on computing machinery, but Turing largely dismissed the argument, pivoting instead to behavioral simulation, the Turing test. Turing argued that if it acts intelligent, we should treat it as intelligent.
But the UCLA study and Jefferson's quote suggests Turing's behavioral threshold isn't enough when it comes to creativity. Simulation is not origin.
And I don't want you to think this only applies to fine arts, like writing sonnets or painting. This distinction translates aggressively into the modern economy. The Forbes article we have, which forecasts the critical skills for the 2026 workplace, highlights an incredibly underrated human capability that is becoming the ultimate differentiator, the concept of taste.
Taste is fascinating because it is inherently resistant to algorithmic optimization. In a commercial setting, an AI design tool can generate 10,000 variations of a marketing campaign, complete with differing color palettes, typography, and copy, all within a few minutes.
The bottleneck is no longer production. It is selection.
Right. It requires human intuition, an intuition forged by deep cultural immersion, instinct, and a nuanced understanding of current societal zeitgeist, to survey those 10,000 variations and instantly identify the one that possesses the correct weight.
The AI gives you infinite volume. The human provides the filter. Which design actually resonates? Which phrasing feels authentic rather than corporate? Taste is the ability to recognize the footprint among the shoes.
You see this dynamic playing out in every industry. Think about a developer architecting a new application. The AI can write the boilerplate code flawlessly.
But it takes a human who understands both the rigid logic of software engineering and the messy, irrational psychology of human behavior to combine those fields and design a user experience that actually changes how people manage their daily lives. AI cannot architect those unique collisions of lived experience.
Which is exactly why attempting to compete with AI on the axes of speed, data retrieval, or structural formatting is a losing battle. We have to fundamentally reframe the relationship. AI is not a competitor for human cognitive origin. It is a mechanism for scaling it.
This brings us to a crucial conceptual pivot. We need to stop viewing AI as a rival entity and start utilizing it as an integrated tool. The Neuroscience News article in our stack introduces a deeply compelling cognitive framework for this relationship, proposing the concept of System Zero.
To contextualize System Zero, we have to look back at the Nobel-winning psychologist Daniel Kahneman's foundational work on human cognition, where he delineated System 1 and System 2 thinking.
System 1 is our brain's fast, automatic, highly intuitive, and unconscious mode of thought, like instantly reading anger on someone's face.
And System 2 is our slow, deliberate, analytical, and effortful mode of thought, like solving a complex math problem or filling out a tax form. Both are entirely internal biological processes.
The researchers propose that AI has evolved to function as System Zero. It is a cognitive processing layer that is entirely external to the biological brain, yet deeply integrated into our analytical workflow.
Think of it as plugging a massive external quantum hard drive directly into your System 2 analytical process.
System Zero can ingest galactic volumes of unstructured data, run complex statistical permutations, and surface invisible patterns in milliseconds. But, and this is the absolute crux of the argument, System Zero cannot assign intrinsic meaning to the data it processes.
Precisely. System Zero provides statistical correlation. The human mind must provide the causal narrative. If an AI analyzes 10,000 customer support transcripts and surfaces a statistical cluster showing a 20% spike in complaints regarding a new software feature, it has successfully executed its function.
But it is up to the human operator to assign meaning to that cluster.
Right. Does this spike represent a fundamental existential flaw in the product's vision that requires an immediate pivot? Or does it merely represent the expected temporary friction of user adaptation? System Zero flags the anomaly. The human must contextualize it within reality.
To understand how massively this System Zero framework is about to reshape the global economy, we have to dig into the macroeconomic data from the Deutsche Bank report. The projections regarding the financial impact of integrating AI as an external cognitive tool are staggering.
They reference a PwC forecast estimating that AI technologies could inject an additional $15.7 trillion into the global GDP by 2030.
That isn't just a marginal bump. That is a fundamental reorganization of global productivity.
And it is vital to parse where that growth is coming from. It isn't primarily coming from autonomous systems entirely replacing human workforces. The report notes that currently only about 10% of complex labor roles across major economic sectors are completely susceptible to direct AI replacement.
The real explosive growth reported by the Bureau of Labor Statistics as a 25% increase over the last decade is in hybrid roles.
Right. These are positions explicitly designed to fuse human strategic origin with AI processing efficiency. The market is aggressively demanding humans who are highly adept at wielding system law.
But wielding a tool of that magnitude introduces massive systemic resource complications. This isn't just software running in the ether. It is built on physical infrastructure. The Archive paper exploring the dual paradoxes of AI brings up the Jevons paradox, which I think is absolutely critical for understanding the hidden costs of System Zero.
The Jevons paradox is a foundational concept from environmental economics. In the 19th century, the English economist William Stanley Jevons was observing the adoption of the steam engine and coal consumption.
Logic would dictate that as technological improvements made steam engines vastly more efficient at burning coal, total coal consumption would decrease because you needed less fuel to achieve the same output.
But Jevons observed the exact opposite. As efficiency increased, the cost of utilizing the energy plummeted, making it economically viable to deploy steam engines into countless new industries. As a result, total coal consumption skyrocketed.
And we are watching the exact same paradox play out with compute and data. As our algorithms become more elegant and as our specialized silicon, our GPUs and TPUs become exponentially more efficient at processing neural networks, we aren't using less energy. We are drastically expanding the scope of what we apply AI to.
We integrate it into every software platform, every supply chain, every creative suite.
Consequently, the massive data centers required to run System Zero are draining local power grids, demanding massive cooling infrastructure, and consuming resources at an unsustainable rate. The tool is highly efficient, but our deployment of it is gluttonous.
This raises an important question. If we are constantly feeding this incredibly resource-hungry System Zero and integrating it into every facet of our digital lives, what happens to the underlying data ecosystem itself?
This is the terrifying concept of model collapse, or the danger of synthetic data, which the Neuroscience News piece touches on. Right now, large language models are trained on the vast archive of human-generated text and imagery, the authentic footprint of human history.
But as AI generates an increasing percentage of the content on the internet, future iterations of AI models will inevitably be trained on AI-generated data.
It creates a degenerative feedback loop.
If an AI model trains on the synthetic output of another AI model, it begins to amplify the statistical artifacts and biases inherent in the original algorithm, while simultaneously losing its anchor to the messy variance of actual human reality.
The output becomes an average of an average, stripped of nuance and origin.
To prevent this synthetic degradation, humans must remain the primary generators of authentic, highly diverse data. We must remain the anchor to reality, or else System Zero becomes a closed, self-referential loop of synthetic noise.
It's the digital equivalent of continuously photocopying a photocopy. Eventually, the fine details wash out, the contrast breaks down, and all you are left with is an illegible blur of static. We have to maintain our position of authority over the tool to prevent that degradation.
There's a fantastic metaphorical framework for this, provided by Christopher Day, a researcher at the Harvard Graduate School of Education. He draws on classical mythology, specifically the depiction of Athena, the Greek goddess of wisdom.
Athena is historically depicted with an owl perched on her shoulder. The owl possesses capabilities that the goddess does not. It has the ability to see clearly in the dark, to rotate its head to view blind spots, and to gather sensory information from a broader, more acute perspective.
Today proposes that we should view AI as the owl.
I love this framing so much. System Zero is your owl. It sits on your shoulder, it peers into the massive dark data sets that your biological brain cannot possibly process. It identifies the statistical patterns, and it whispers those insights into your ear.
But, and this is the absolute non-negotiable requirement, you must remain the deity of wisdom.
Yes, you synthesize the owl's insights with your lived experience, your moral compass, and your strategic vision. You make the final call. The owl serves the human. The human must never subordinate their judgment to the owl.
It is a vital hierarchical distinction. When we look at the historical timeline of technological anxiety, from the printing press to the Industrial Revolution, new tools always provoke fears of human obsolescence. But historically, tools have always functioned as levers that allow humans to move faster and think on a grander scale.
The invention of the electronic calculator did not eradicate the mathematician. It liberated them from the tedious drudgery of long division, allowing them to redirect their cognitive surplus toward theoretical physics and advanced topology.
The internet did not render the research scientist obsolete. It provided instantaneous access to global archives, accelerating cross-disciplinary breakthroughs.
AI is simply the next iteration of that leverage. It is the most powerful lever we have ever constructed, but it is still just a lever. And using that lever effectively requires a category of intelligence that algorithms cannot even begin to simulate. We spent a lot of time discussing cognitive flexibility, neuroplasticity, and the origin of creativity. But as we synthesize the final components of our research stack, we arrive at the absolute core of the human advantage, the intelligence of character.
Intelligence of character encompasses a suite of deeply human traits: wisdom, empathy, integrity, vulnerability, and moral judgment. These are not data points. They are qualities forged exclusively through the friction of the human condition.
And artificial intelligence does not understand mortality because it is not finite.
It does not understand physical pain. It has never experienced the irrational complexities of love. It cannot feel the weight of a cultural identity. And it does not possess a biological imperative to survive.
It can beautifully simulate a response based on the statistical distribution of human literature, but it entirely lacks the lived reality that gives those concepts actual weight.
The Forbes article, analyzing the workplace dynamics of 2026, makes this distinction crystal clear. As the hard skills coding, data analysis, basic copywriting become entirely commoditized by AI, the skills experiencing a massive premium in the labor market are explicitly these human skills.
Let's look at this through the lens of the ethical dilemmas raised in the Deutsche Bank report, specifically focusing on the concepts of accountability and moral agency.
This is often referred to as the accountability paradox in AI ethics, and it is a massive structural barrier to full automation in high-stakes environments. Consider the deployment of a highly advanced, fully autonomous, AI-driven robotic surgeon.
Okay, setting the scene.
The system analyzes the patient's scans, calculates the optimal trajectory, and executes the procedure. But if that robotic system encounters an unforeseen biological anomaly, miscalculates, and causes critical harm or death to the patient, who is legally and morally accountable.
Exactly. You can't put a server rack in prison. Is the accountability assigned to the supervising doctor who trusted the machine? Is it the hospital administration that purchased the software?
Is it the team of developers at a tech company thousands of miles away who wrote the initial algorithmic architecture? Or is it the regulatory body that approved the medical device?
Because autonomous AI systems are not conscious, they are fundamentally incapable of being moral agents. They have no consciousness to experience guilt, no personal assets to pay financial restitution, and no liberty that can be legally revoked by a justice system.
Because a machine cannot be held accountable, it cannot be trusted with ultimate moral authority. In high-stakes environments, medicine, law, defense, strategic leadership, human oversight, human judgment, and the human capacity to bear the moral weight of a decision remain absolutely irreplaceable.
An algorithm can optimize a surgical path, but an algorithm cannot sit down in a waiting room, look a grieving family in the eyes, and explain what went wrong. That requires the intelligence of character. And the Forbes article highlights other critical areas where character is the ultimate currency, such as conflict navigation and trust building.
Let's be honest, AI is inherently conflict averse. Most LLMs are rigorously fine-tuned to be helpful, polite, and to optimize for the smoothest, most consensus-driven path possible. But human progress is rarely born from consensus.
Progress often requires intense friction. Whether you are in a volatile tech startup, a collaborative creative studio, or attempting to navigate a complex geopolitical negotiation, humans will disagree. Founders will have wildly divergent visions for the future of a product. Egos will clash.
You need human leaders possessing high emotional intelligence to navigate that conflict, mediating between competing egos, reading the unsaid tensions in the room, and synthesizing opposing viewpoints into a unified breakthrough. AI cannot mediate human ego because it doesn't possess one.
And building genuine trust is inextricably linked to our physical humanity. An AI can instantly draft a perfectly polished, highly persuasive email to 10,000 prospective clients simultaneously. But it cannot sit across a table from a skeptical partner and shake their hand.
High-level business deals, delicate political treaties, and deep collaborative partnerships are still fundamentally built in physical environments. They rely on microexpressions.
They rely on sensing a partner's hesitation, knowing precisely when to pause the pitch, and creating a framework of psychological safety where individuals feel comfortable sharing vulnerability. Trust is not an optimizable data point. It is a biological consensus established over time between conscious entities.
The Forbes piece provides a highly illustrative, albeit harrowing, example of where algorithmic efficiency completely fails without the overlay of human character. Imagine a corporate environment where human resources and management are entirely dictated by an AI dashboard. The system flags a mid-level employee who has consistently missed their sales targets for 3 consecutive quarters. The algorithm, designed strictly to optimize for quarterly financial efficiency, processes the data and spits out a binary recommendation. Terminate. If you view the company merely as a mathematical equation, termination is the correct answer.
But the human leader possesses context that the dashboard cannot process. The human leader knows that this specific employee just lost a parent to a protracted illness. They know the employee has been acting as a primary caregiver, is dealing with severe, compounding burnout, but historically, prior to this tragedy, has been one of the most dedicated, deeply loyal members of the team.
The AI only understands the recent statistical pattern. The human leader understands the complete human story.
If a leader abdicates their moral agency and relies solely on the AI dashboard's recommendation, they fire the employee. They optimize the immediate spreadsheet, but in doing so, they actively build a toxic, high-turnover nightmare of a corporate culture.
The rest of the team watches how vulnerability is punished, psychological safety evaporates, and everyone begins operating in a state of self-preserving fear.
But the leader who integrates the data with emotional judgment, who understands the broader context, might choose to override the algorithm. They might grant that employee a temporary sabbatical or shift their role to something less demanding while they recover.
That decision isn't mathematically optimal in the short term, but that leader builds fierce, generational loyalty. They build long-term resilience within their team. The machine understands the metric. The human understands the meaning.
We are rapidly transitioning into an era where being purely analytical is no longer sufficient, precisely because the machines will always be vastly superior analysts. The premium in the future economy and in society at large is now firmly placed on being profoundly, unabashedly human.
So bringing this entire deep dive back to the central question we posed at the beginning. Can humans still be smarter than AI?
The answer is a definitive, resounding yes. But it requires an active, conscious choice to evolve. If you attempt to compete with artificial intelligence on its home turf, if you define your intelligence by your ability to memorize facts, produce standardized reports, and prioritize raw processing speed, you will inevitably be replaced by a script.
The mandate for you navigating this landscape is clear. You must fiercely protect your biological mental map. Do not allow the frictionless convenience of AI to induce cognitive atrophy. Actively embrace the agonizing, messy, unstructured friction of learning new skills.
Cultivate your authentic creativity by drawing deeply on your unique emotional architecture, your cultural heritage, and your personal history, ensuring you are leaving a footprint, not just manufacturing a shoe.
Utilize these powerful neural networks as your system zero owl. Let it process the vast oceans of dark data. Let it surface the statistical patterns, but demand that you remain the sovereign deity of wisdom calling the shots.
Artificial intelligence is, without question, the most powerful tool our species has ever engineered. But a growing, emotionally grounded, deeply curious, and biologically adaptable human mind remains infinitely more powerful.
To leave you with a final thought to mull over as you navigate this rapidly shifting reality, we've spent the last hour discussing the mathematical limits of AI, the bounding box of algorithms, and the boundless, incomputable nature of human thought. I want you to consider this. If human general intelligence is a mathematically incomputable process and AI is designed to constantly optimize for the average high consensus output, consider this. Will the greatest human geniuses of the future be recognized not by their ability to produce perfect answers, but by their ability to produce beautifully flawed, messy, mathematically incorrect leaps of logic that an algorithm would have automatically deleted?
Wow. That is exactly the kind of fundamentally human question an AI would never even conceptualize. Thank you so much for joining us on this custom deep dive. Keep asking those messy questions, keep your owl firmly on your shoulder, and stay fiercely curious. We'll see you out there.